Hi, I'm John Ohanian from AVID LLC, here to give a demonstration of the morphing flight control actuation technology that we've been developing under a Phase 2 SBIR for the Airforce Research Laboratory's Munitions Directorate. The intent of this research is to eliminate servos, linkages, and small moving parts from UAVs, or unmanned aerial vehicles, as those components tend to decrease the reliability of those systems. This is the morphing flight control technology applied to a control surface of a thick airfoil wing. You can see the conformal shape-changing ability due to the electrical input to the structure. So just to show you the comparable deflections between the morphing and the servo. And I'll put it into a sine wave, which tracking a 50% sine wave signal. And then as the frequency goes up, you can see them both tracking to a certain extent. When you get all the way up to, this is about 20 hertz, the MFC is still tracking the signal, albeit at a smaller amplitude, but the servo is absolutely still. It can't really track a signal that fast. So that shows the added bandwidth of the morphing actuation. I'm bringing the frequency back down to slower values. That's about 4 hertz. That's 1 hertz there. Next, we'll show some flight tests of a vehicle that was completely controlled through morphing actuation, both the aileron and the elevator control surfaces. The aircraft was hand-launched and then manually flown by the pilot into a racetrack pattern. From that pattern, we would execute automated roll and pitch doublets to assess the control power. The main objective of these tests was to compare the control power of the morphing flight control actuation approach to a traditional servo-actuated flapped control surface approach. As the vehicle is preparing for these maneuvers, you can see it's smoothly flying, and the pilot had remarked that it was very responsive. So one of the roll doublets is coming up here. This is how we assessed the roll power right there. And this is just a second example of some of the flight tests of the roll doublets. So you can see the vehicle performing quick roll movements. We also assessed the pitch authority. You can see the quick pitch up maneuver there. And then a second pitch doublet is coming up here. And then it kept climbing there. Now the vehicle also did not have landing gear, so we did a deep stall landing maneuver, and the morphing flight control surfaces were never damaged in any of these cases. The next flight test video is of a thin morphing wing design where the entire wing twists during roll actuation. This shows the twisting actuation of the thin morphing wing, as well as the morphing elevator that was used in all tests. The thin wing design was hand-launched, just like the baseline morphing case. We performed roll doublets with this design as well. Because the whole wing morphs, it has the capability of even higher roll rates. To summarize the technical accomplishments of this Phase 2 SBIR, we reached a technology readiness level of TRL 6 with the morphing technology. We had a successful flight test program and achieved roll rates up to 250 degrees per second within a 0.2 second span. We developed custom lightweight electronics to power the morphing actuators. We achieved 1 million cycles without failure in the reliability testing, showing the potential benefit over servos. And finally, we demonstrated a 10x improvement in the control bandwidth over servos. These technical accomplishments translate into customer benefits. The superior reliability of the morphing actuation would reduce UAV failure rates and downtime, thereby increasing mission effectiveness. This increased reliability will reduce the overall life cycle cost and also decrease the probability of losing a complete vehicle and sensor payload system, which is a significant cost to consider. In terms of performance, the faster vehicle response time and control bandwidth will translate to enhanced mission capability, such as operating in complex urban environments, enhanced terminal guidance, or operating in gusty and turbulent conditions. Thank you for your interest in AVID's morphing flight control technology. Please feel free to contact me if you have any questions or would like more information. Thank you.